We're now on to the second part of organic chemistry, which is based on intermolecular forces and boiling points of organic compounds. Here we have a question 3 that says, a learner investigates the relationship between the compounds W, X, Y, Z and their boiling points. The results obtained were recorded as shown in the table below. So if we have a quick look at these compounds, we notice that we are working with alcohol. So W, X, Y, and Z are all alcohols. Another thing we notice is that starting off with W, which is ethanol, ethanol contains 2 carbons. Then we go on to X, propan. Propan is 3 carbons. Y, butane. Butane has 4 carbons. And Z, pentan. Pentan has 5 carbons. So what we notice from top to bottom is that the chain length increases. Now on the right hand side, we've got their corresponding boiling points. And here we see that boiling point increases from top to bottom. Now this makes sense because we know that when it comes to chain length, as the chain length increases, the surface area of the compound increases and the boiling point increases because more energy is required to overcome the intermolecular forces. So what we have here makes total sense, but before you answer the questions, always analyze the table that you have, identify the trends, identify the homologous series, identify what is changing in each compound. Now 3.1 says define the term boiling point. This definition of boiling point stays the same as the one that you learned in grade 10. Boiling point is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. So here's your definition. The temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. Now 3.2 says write down the name of the functional group of the compounds W to Z. So we've already identified these as belonging to alcohols, and we know that the name of the functional group of alcohols is the hydroxyl group. So 3.2 is hydroxyl group. So that is the OH that it contains as the functional group. 3.3 says for this investigation, write down, and the first thing we're looking for is the dependent variable. Now a way that you can remember this is the dependent variable is what you are measuring in an experiment. So for this experiment, we are measuring the boiling point for each compound. So our dependent variable here is boiling point. (3.3.2) we need the independent variable. So independent variable is if you are carrying out this experiment, what are you changing each time? So when we look at the compounds, what was changed each time was the chain length. So we notice that we started off with ethanol, then we went to prop, then bute, then pent. So for this experiment, chain length is our independent variable. 3.3.3 says the conclusion that can be drawn from the above results. What we notice here, and I mentioned it at the start, is that from top to bottom we notice that as the chain length increased, the boiling point increased as well. So that is the conclusion. So this is what we've observed. And another way of saying this is that chain length and boiling point are directly proportional. 3.4 says, which one of the compounds W or X has a higher vapor pressure? Give a reason for your answer. Now you guys must remember, vapor pressure and boiling point are inversely proportional. So if you're looking for the compound with the highest vapor pressure, it would be the compound with the lowest boiling point. So from our table, the compound with the lowest boiling point is ethanol. So 3.4 is W, which is ethanol. And your reason is going to be that it has the lowest boiling point. So extremely important for you to remember that boiling point and vapor pressure are inversely proportional. Often when they ask you questions in terms of vapor pressure, we are given values in terms of boiling point. So we always understand it the opposite way for boiling point. Like here, where they wanted the compound with the highest vapor pressure, we looked for the compound with the lowest boiling point. 3.5 says, use the information in the table to explain the difference in boiling points of compounds Y and Z. So let's have a look at those two. Compound Y is butane-1-all. So compound Y obviously contains 4 carbons in the parent chain. And compound Z is pentane-1-all. So compound Z contains 5 carbons in the parent chain. So we can actually start off with that as our first point. Okay, so I start off by saying compound Y contains 4 carbon atoms in its parent chain, whereas compound Z contains 5 carbon atoms in its parent chain. Now, while we're on this point and we've compared them, we're going to state which one has the larger or the longer chain length. So I'm going to say, therefore, compound Z has a longer chain length. Now remember that chain length has to do with surface area. The longer the chain length, the more space the compound occupies. That would mean that compound Z has a larger surface area than compound Y. So since compound Z has a larger surface area in terms of intermolecular forces, we know that more energy would be required to break the bonds in compound Z than in compound Y. So more energy is required to overcome the intermolecular forces in compound Z than in compound Y. And to conclude, we can say, therefore, compound Z has a higher boiling point. So when it comes to chain length always relates to surface area, and compounds with larger surface areas require more energy to overcome those intermolecular forces that hold the carbon atoms together. That is why it has a higher boiling point. Okay, so 3.5, that is it. Please remember to like, subscribe, and turn on your notifications for more content.